Most people believe that every house needs columns to stay standing. After all, columns are what hold buildings up, right? But what if I told you that some homes can be built with no columns at all? In fact, removing columns isn't always a mistake. It can sometimes be part of the design. So how is that possible, and what actually keeps these houses from collapsing? Welcome back to Next Gen Home Builders channel. If you look at almost any modern commercial building or residential construction site today, you will see a familiar skeleton. Vertical concrete columns reinforced with steel rebar cages, or heavy structural steel I-beams shooting straight up into the sky. Because of this, the general public automatically associates structural strength and stability with these vertical pillars. We are conditioned to think that without them, gravity wins. But as structural engineers, we look at a building differently. We don't see individual elements. We track the continuous flow of forces down to the earth. So if columns disappear entirely from an architectural blueprint, what carries the load? The answer is a masterclass in structural physics, and it begins by breaking down what a column actually does. To understand how to delete a column, you first have to understand its true mechanical purpose. In a standard post and beam frame system, columns act as highly concentrated vertical point load pathways. The weight of the roof deck passes into horizontal lumber rafters or steel roof beams. Those beams then channel that weight horizontally until it hits a vertical column, which compresses and forces that load straight down into an isolated concrete footing pad in the foundation. But here is the major twist that surprises most homeowners. Columns are only one specific method of solving the gravity equation. They are not a universal requirement. In fact, relying heavily on columns forces an engineer to deal with intense, concentrated stress points where the beam meets the pillar, a vulnerability that requires massive amounts of deformed steel rebar to prevent punching shear failure. If columns aren't the only solution, what are the alternatives? The alternative has actually been right in front of us for thousands of years: load-bearing masonry walls. Before modern reinforced concrete and structural steel beams existed, ancient builders and traditional home builders didn't use columns for standard residential layouts. Instead of concentrating the weight of the roof onto a few isolated points, they distributed the dead load evenly across the entire surface area of the perimeter walls. When you build thick walls out of brick, stone, or interlocking concrete blocks, the wall itself becomes the continuous structural column. The compressive force travels down the entire linear footprint of the wall, spreading out perfectly into a continuous strip footing foundation. Most viewers have no idea that the traditional, charming brick house down the street doesn't contain a single vertical column. The entire envelope is doing the heavy lifting. But removing columns altogether creates a massive modern comeback. Currently, we are witnessing a massive architectural resurgence of column-free design, driven heavily by luxury minimalist homes and the demand for sweeping, open-plan living spaces. Modern architecture wants to delete internal barriers. Homeowners want a seamless transition where the living room flows completely into the kitchen without a single vertical post obstructing the view or breaking up the floor layout. To achieve this aesthetic, modern engineers utilize advanced structural wall systems, engineered lumber trusses, and high-performance cross-laminated timber panels. By pushing the structural walls completely to the extreme outer perimeter of the home, we can create vast, open interior spaces that look impossibly light and hollow. But removing these internal columns creates a severe engineering challenge that pushes materials to their absolute physical limits. Here is where we create intense structural tension. Just because internal columns can be removed from a design does not mean they should be without a massive budget adjustment. When you delete an internal supporting column, you are drastically increasing what engineers call the structural span. In a standard framed home, a horizontal floor or roof beam might only need to span 12 feet before it hits a supporting column. If you remove that column, that same horizontal member might now have to span 30 or 40 feet across the open room. According to structural mechanics, as a beam's span doubles, its deflection, or its tendency to sag under load, increases by a factor of 16. If a builder tries to bridge that massive gap using standard residential lumber rafters, the center of the roof will slowly sag, warp, and eventually suffer a catastrophic bending failure. You cannot just delete a post without completely re-engineering the overhead horizontal framing. So, what actually replaces the columns in a high-end, open-plan home? This is where true structural engineering shines. To eliminate vertical posts, we must drastically upgrade the section modulus and stiffness of our horizontal elements. We replace standard lumber rafters with deep structural steel I-beams, or massive, custom-fabricated steel transfer beams hidden entirely inside the ceiling cavity. These heavy steel profiles are engineered to handle immense bending stresses without deflecting a single millimeter. Furthermore, we integrate strategically placed concrete shear walls or structural wood-sheathed shear panels into the exterior envelope. These shear walls handle the lateral wind loads and seismic forces that internal columns would normally stabilize. The load path is shifted, amplified, and redistributed through high-strength materials concealed behind the clean, flush lines of the drywall. But building without columns becomes incredibly dangerous when uneducated homeowners or unlicensed contractors attempt to modify a house during a renovation. People look at a drywall barrier and assume it's just a partition separating two rooms. They tear it down to create an open-concept layout without consulting a structural engineer. If that wall was a load-bearing masonry wall or a primary lumber stud wall carrying the weight of the floor joists above, the consequences are immediate and terrifying. Without a deep steel transfer beam installed to carry that newly unsupported span, the upper floor plate will undergo progressive deflection. Doors will jam, structural cracks will rip through the ceiling plaster, and the entire roof structure can experience a sudden, unannounced structural collapse. People love open spaces, but water and gravity do not care about aesthetics. Can a house be built without columns? Absolutely, yes. But only if another properly engineered system takes over the high-stakes job of carrying those loads safely down to the foundation. The idea that every house must have columns is one of the most common misconceptions in construction. The reality is that buildings don't depend on a specific element. They depend on a complete load path that safely transfers forces to the ground. Whether that path involves columns, walls, or other structural systems, good engineering is what keeps a building standing. And that's what ultimately matters. If you respect the uncompromised physics of building science, hit that like button to help us push this analysis through the algorithm. Don't forget to subscribe to the Next Gen Home Builders channel and turn on all notifications so you never miss our deep structural breakdowns. Let me know in the comments. Do you prefer columns or open spans? Thanks for watching, keep your tolerances tight, and I'll see you in the next analysis.